All right, guys, problem number 2 on the 3.1 worksheet is asking us to find the derivative of this function with respect to x. So since they've done this in Leibniz's notation of just putting a y there, we're going to call our derivative here dy dx, but that's the same thing as f prime of x, guys. So we've got our formula right here, which I'm going to write out since we're just getting started. A limit as h approaches 0 of, and I'm going to go ahead and use function notation, even though this one was called y. Easier to learn just this one version of the formula. So f of x plus h minus f of x all over h. So let's see where that gets us right here. Limit as h approaches 0 of, okay, and here we go. The first part of the numerator is the hard part. F of x plus h means that everywhere there was an x in the original function here, we're going to replace it with the binomial quantity x plus h. So this is going to be 2 times x plus h in parentheses quantity squared. That takes the place of the 2x squared, and then there's a plus 5 at the end of all that. Minus, and now the f of x, because it's a polynomial, in this case a binomial, you really want to be sure to put parentheses there, but f of x is just the original function with no changes, 2x squared plus 5, all over h. Now the first thing we would try in any limit problem is plug and chug, but of course this 0 plugged into the denominator creates the problem that we're used to seeing. We can't divide by 0. So that's why we try to do some algebraic manipulation and see if we can evaluate this limit in kind of a roundabout way, and I think we're going to be able to do that. In fact, I know we are, because every single polynomial works in this format, guys. Okay, so what we're doing here now first is we're going to expand that binomial of x plus h quantity squared, and just in case you guys need to write this down somewhere, let's remember that a plus b quantity squared does not equal a squared plus b squared, guys. You cannot just distribute the exponent into a polynomial base, although the answer is actually closer to that than you might think. Well, now hang on, I didn't want that. So if you need to write this down, a plus b quantity squared is going to be a squared plus it's the first term times the second term times 2. So that's going to be a 2ab and a plus b squared. So we're going to have x plus h quantity squared, and we're going to distribute the 2 in there as well. Now, if you get good at this, guys, this is something you can do in one step. But I think for now, I'm going to go nice and slow and try to keep it in terms of one step at a time. So the 2 is just tagging along, and squaring the x plus h is going to give us an x squared plus a 2xh, and then plus an h squared. Okay, and then there's a plus 5 still lingering at the end of all that. And then, I guess I might as well go ahead and get to this now. There's nothing to do at the end here except distribute that minus in there. So that'll be a minus 2x squared and a minus 5 all over h. Okay, so now our next step is going to be to distribute this 2 into that trinomial, and there's no like terms to combine that 5 with right here, so I think that's going to be, all I'm going to be able to do at this point. So let's see if I can't move this around a little bit here, guys. Sorry. Do this old trick. If I draw something at the bottom, there we go. Now I can zoom in where I want to be. Okay, so what's that going to get us now? Still not ready to evaluate this limit just yet, but here we go now. That is going to give us a 2x squared plus a 4xh plus a 2h squared when we distribute the 2. There's a plus 5 at the end of that, and then a minus 2x squared and a minus 5 all over h. And now comes the fun part, guys. First of all, in every single polynomial function that you do, like we're doing right here, all of the terms in the numerator that don't contain an h are going to drop out. Don't take my word for it, but it happens every time. Here's a 2x squared and a minus 2x squared, gone. There's a plus 5 and a minus 5, gone. And you're left with these two terms right here, both of which contain an h. So what are we going to do here? This, again, is something you might learn to shortcut a little bit in the future, but for now, let's go nice and slow. I'm going to factor out the h from those two terms in the numerator, leaving us with a 4x plus 2 times just 1h, all over that h on the bottom. And this is the moment we were waiting for, guys. The h's on the top and the bottom cancel out. So now we can go ahead and do plug and chug. And let's remember, it is h that is becoming 0, not the x right here. So that x is just going to remain 4x, but then it's going to be plus 2 times a value of 0, and we're just going to end up then, let me not do that here, we're just going to end up then with 4x for our answer. And if we went back to the top right here, remember that what we're finding, guys, is the derivative of y with respect to x, and that is our answer. Kind of buried in that corner there. dy dx is equal to 4x. Now, I just want to remind you guys of a couple of things. You learned some shortcuts for derivatives last year in pre-calc, and if you thought about that already, I think you guys remember that, yeah, the derivative of 2x squared plus 5 would have been 4x, so that one checks out. But also, let's remind ourselves, the definition of the derivative, verbally speaking, everybody, is an expression that we can then use to evaluate the slope of the tangent or the instantaneous rate of change of this function at any particular value of x. So that's what number 2 looks like, that being a quadratic function. Number 3 and number 4 on this worksheet are quadratics as well, although those ones also contain a linear x term. So you're actually going to have 2 of these x plus h's in that first set of brackets there, which makes those problems a little bit more complicated. But I have total faith in you guys. You'll do awesome. Go get them.